an example problem for finding the Thevenin equivalent. And we're going to go ahead and find our Thevenin first. So to find our Thevenin, we want to remove the load and deactivate our independent sources. Remove load and deactivate sources. Okay, so our load is here. Our points A, B. We're trying to find a Thevenin equivalent for this circuit with 1 ohm being our load. So we're going to chop that off. We're going to deactivate our voltage source by shorting it out, changing it to a line. Deactivate our current source by opening it. We want 0 current. We need a big old hole. So let's redraw that. So there's where my voltage source used to be. Done nothing to my 6 ohms. Current source is now a big hole. I'll have another 6 ohms, 4 ohms, and here's points A, B. We've cut off the load. So we want to find our Thevenin, or the resistance seen right here. So it's an REQ, right, which we did, I don't know, chapter 2 or 3, I can't remember. All right, so let's look at these. Now that this source is gone, 6 and 6 are exclusively sharing this node. If they're exclusively sharing that node, they're in series. So I can redraw this. You don't always have to redraw these steps, but if it helps you, definitely do it. So I have 6 plus 6 equals 12. That's an ohm symbol. That's just really sad looking. And now I have the 12 and 4 in parallel. So my R Thevenin will be 12 in parallel with 4. Or 48 divided by 16, 3 ohms. So that's how we find our R Thevenin. To find our V Thevenin, we want to look at our V open circuit. So we want our original circuit here, but with an open circuit right here where the load goes. So we want to find V Thevenin. Find VOC, or V open circuit. So I have that exact circuit over there without the load. So there's points AB, or V open circuit, or V Thevenin, whatever you want to call it. This is 4 ohms, 6, 6, 3 amps, and 18 volts. So let's find our V Thevenin. Now, we have options, right? We can do mesh, we can do nodal. You could do superposition, though that would be completely unnecessary. I like nodal when we're trying to find a voltage because your answer is the voltage and you're done. So since V Thevenin is right here, that means this voltage we can call V Thevenin. Let's go ahead and call this Vx. And we don't need to call this one anything because we know the voltage there. That's a case 1. We have 18 volts right there. So I have Vx minus 18 over 6. I have 3 entering, minus 3, plus Vx minus V Thevenin over 6. Equals 0. So I could reduce that equation by combining like terms. I'm not going to do that because I trust that you can do algebra. If you can't, you have a problem being in this class. V Thevenin minus Vx over 6. Plus V Thevenin minus 0 over 4. I will skip writing the minus 0. And that's it. So I don't need a plus sign there. I just need to say equals 0. So I solved these equations And I get a Vx that is equal to 22.5 volts, and a Vthevenin that's equal to 9 volts. So my Thevenin equivalent looks like this. R Thevenin is 3 ohms, V Thevenin 9 volts, and it's going to my load, which is after AB, at 1 ohm. So there's my new circuit. These two circuits say the exact same thing. We were also supposed to find I. I is still right there. And I is pretty easy to find now, right? R Thevenin and the 1 ohms are in series. V equals IR. So I have 9 equals I times 3 plus 1, or I equals 2.25 amps. So we'll do one more Thevenin equivalent example in the next video.